In this video series, I've worked through a math problem or problems each video. In applied mathematics, we sometimes come across very large or very small numbers. If these numbers are written out as we usually write the numbers, we either end up with a large number of zeros at the tail end of the number or at the start of the number. Though these are valid ways of writing these numbers, they may be difficult to write, read, and understand. Because of this, we often write these numbers using something called a scientific notation. Scientific notation takes a number and rewrites it as a number multiplied by a power of 10. This number is derived from the original number by moving the decimal point one digit after the first non-zero digit. The power of 10 is chosen so that if the multiplication of the number in the scientific notation is carried out, we get the original number back. Let's take a look at the examples. Rewrite each number using scientific notation. This first number is pretty large so that it's even hard to just determine what it is. So let's go ahead and add the commas to help us read this number. This is a thousands unit, 10,000, 100,000, 1 million, 10 million, 100 million, billion. So this number is 332 billion. So if we want to use a scientific notation to rewrite this number, we move the decimal point from here all the way to the location right after the first non-zero digit. The first non-zero digit is this 3 here. So we write the decimal point after the first 3, and we get 3.32 multiplied by 10. And we want the exponent here so that if we multiply 3.32 by this number here, we get the original number back. So if we start from here, we need to move the decimal point to the right by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 digits. So the exponent is 11, and the original number, 332 billion, can be rewritten as 3.32 multiplied by 10 to the 11th power. Next, we have the number 0.000000067. So if we use the scientific notation to rewrite this number, we first move the decimal point to the right of the first non-zero digit. The first non-zero digit is the 6. So we write the decimal point right after that and multiply it by 10. And once again, we need to figure out the exponent. If we start the decimal point here, then to get the original number back, we need to move the decimal point by 1, 2, 3, 4, 5, 6, 7, 8 digits. So the exponent here is minus 8. So the original number 0.000000067 can be rewritten using the scientific notation as 6.7 multiplied by 10 to the minus 8 exponent, minus 8 power.